Hi, this is John Scarden. Thanks for taking time to listen to a quick presentation. I've got a couple of ideas I'd like to share with you today about some new ideas for undergraduate research. So a little bit on the background. We have a lot of challenges we're facing in the Central Coast, and a lot of these have to do with externalities created by agriculture or lots of people living in one area, our sort of overuse of the local groundwater. And some of them are driven by things like we can't control, like drought, and others like climate change, which we don't really know what's going to happen, but we have some general ideas. And we know that these so-called common pool problems are pretty common in areas where there's prolonged drought, where we have coastal areas because of the migration of people long-term toward coastal cities, proximity to major population centers or industrial areas, and of course, anytime we have drinking water supplies located near large-scale agriculture or confined animal feed operations. So I think there's an opportunity here to expand the UROC opportunities for our ESTP majors and others that are interested. And I'm going to lead some of these projects or co-lead if there's another faculty member who's interested. So to give you a quick example, one of the project's ideas that I got from one of my students was the idea of how do we treat this agricultural runoff water. It's got a lot of nitrate and other stuff in it, and we know that the nitrate is not good in the drinking supplies. Now, this is not a technical problem per se. We know how to treat nitrate. But the student was exploring an idea that she had been working on with Mark Los Huertos about, can we use an existing, let's say, column of soil and somehow coax the soil bacteria to remove the nitrates for us? So the more I kind of dug into this, I said, well, wouldn't this be a great research project where students could work with all sorts of different types of bacteria, look at different flow rates, and then perhaps even things like enhancing the activity of the bacteria by injecting carbon dioxide into the soil column from the bottom, and see if that might make it more efficient. If we make it more efficient, we can decrease the size or increase the flow rate of the ag water going into it. So here's a simple cartoon that I developed that kind of explains the very inexpensive apparatus to run this research. It basically consists of a piece of 12-inch diameter PVC pipe with some holes drilled in it, and it sits up vertically, so we get all the normal soil dynamics going on. And then we have some ports for sensors, and we measure the water going in, the water coming out. And there's a lot of stuff already published on this basic idea in soil physics textbooks. But this would be a very interesting way for students to explore all sorts of different possibilities. So a little more quickly, so another sample project is, would be, how do we treat existing waste materials? How do we use existing waste materials to remove contaminants from stormwater runoff? This is clearly a global problem. As we well know, that the storm drains aren't necessarily treated, but they do contain a lot of stuff we don't want in Monterey Bay, for example. And I got this idea from a friend of mine who studied a problem of how to deal with all the leaves that we have to sweep up in Portland, Oregon every year. And he had this crazy idea that, well, why don't we see if we can use the leaves for some environmental purpose rather than spending all this carbon in the form of gasoline and diesel to go sweep up all the leaves. So it turned out that it was a brilliant idea, and it turned into a company called Stormwater Management. So I was thinking, wouldn't that be a cool idea that you could do this locally, because each local area is going to have its own kind of available materials to do this with. So Monterey would have to do something local or reasonably local. And I think this also would give the students a wide variety of things they can experiment with. And we can use all the storm drains on the Fort Ord property to do the work. We don't have to go into the city. Example project 3, just going a little more quickly, look specifically at how to decrease per capita water consumption in the Central Coast. We already know that while we're really good in California, we're not even close to where the Israelis are in terms of being able to measure water by the drop. And this is also one of those global problems where water supplies are dwindling and they become contaminated, or in other cases where the costs are just rising very rapidly. So there might be a couple approaches to this one. Policy approach, my specialty, which is investigating how some innovations in policy could help local ag water users be more implement more water conservation methods. And perhaps a technology approach also, explore new markets and applications for water saving in uh, the areas that we can control and we do measure, which is residential hospitality or residential, commercial, and industrial users. So one more. Um, it's pretty clear that the Monterey Shale is going to be exploited for oil at some point in the near future, as soon as they can figure out exactly where to drill the wells. So I was thinking, I said, one of the big problems, of course, is that this technique is going to spread to every continent where there's shale oil available. So if we can solve a bit of the problem here, we could certainly export our solution or tell the world about our solution. And we might focus specifically on what's called produced water, which is water that is a combination of stuff that's injected into the well and what they pump out of the well, because sometimes they do tap into water sources as they're drilling into the shale. But that produced water, which can be in the hundreds of thousands of gallons, contains all sorts of nasties that we don't want in the groundwater or in our surface water. So perhaps the students could work with the oil companies to figure out very low-cost ways to do some preliminary treatment of the produced water. And for your information, produced water is an oil term. So basically, kind of wrapping up, if you could send me an email with your thoughts on these ideas, some recommendations, uh, and then just use my email address there, I'd be really, really thankful. And thanks for your time.